All right, let's jump right into today's explainer, looking at AlphaCan Defense Group's newly launched Guardian Cloud platform. If you've been tracking enterprise cloud infrastructure, you know the old ways of handling modern threat vectors are, well, they're basically obsolete at this point. Today, we're going to unpack exactly how Guardian Cloud is completely flipping the script by replacing legacy manual monitoring with a fully autonomous, sovereign AI perimeter. It is a massive paradigm shift.
Here is our roadmap for today. We'll start with AlphaCan's corporate origins, dig into the asymmetry of speed and modern threats, and then break down their autonomous multi-agent architecture and dynamic consensus protocol. Finally, we'll wrap up with their human-in-the-loop governance and AI coding and audit features. Let's get to it.
Section 1. AlphaCan Corporate Origins. Let's quickly establish the foundation here.
Look, before you hand an AI the keys to your mission-critical servers, you absolutely have to know who built it and where it lives jurisdictionally. As you can see right here on this certificate of incorporation, AlphaCan Defense Group Limited is a fully registered UK entity. And that's not just some trivial detail. Operating under strict British corporate law guarantees absolute data sovereignty. We're talking about an elite, air-gapped, secure perimeter with literally zero external API dependencies. That is exactly the level of isolation and reliability you need for high-stakes enterprise defense.
So who is this actually built for? The key takeaway here is massive scale. This isn't your average lightweight SaaS tool for a 10-person startup. Guardian Cloud is engineered for government structures protecting critical infrastructure from advanced persistent threats. It's built for major commercial banks and fintechs that need to scale rapidly without constantly inflating their site reliability engineering headcount. And it's a huge play for data centers wanting to offer white-label autonomous sysadmin as a premium service to their own clients.
Moving to Section 2, the asymmetry of speed. Why do we even need this radical shift in architecture?
Why can't we just stick to the traditional DevOps playbooks? Well, it all boils down to the asymmetry of speed. We are dealing with a brutal disconnect right now. Automated attacks, using 0 days and massive botnets, achieve full compromise in minutes, sometimes seconds. Meanwhile, classical monitoring relies on human-driven SOC teams that take hours in mean time to respond. The attackers are heavily automated and moving at warp speed, while defenders are still relying on human reaction times.
And this bottleneck is exactly why legacy pipelines are failing. As we see here, just throwing more linear monitoring engineers at the problem doesn't fix it. It just creates catastrophic alert fatigue. You've got humans manually parsing thousands of non-critical logs, completely overwhelmed, while the actual damage is already being done in the background. It is wildly inefficient economically, and technically, it's just dangerous. We absolutely have to close that reaction time gap.
Which brings us to Section 3, autonomous multi-agent architecture.
To actually solve this, AlphaCan takes human reaction time completely out of the initial localization phase. We are moving way past yesterday's rigid automation. Over on the left, you've got your static Ansible or Terraform scripts, code that only does exactly what a human tells it to do. But on the right, Guardian Cloud shifts to a two-tier ecosystem powered by an autonomous multi-agent system. It's essentially a digital assistant that independently localizes incidents, generates patches, and isolates threats on the fly. It pushes applied AI and cybersecurity ahead by years.
At the very top of this architecture sits the master agent. Think of it as the core brain or orchestrator of the AI core. It manages highly specialized subagents, specifically sysadmin agents handling OS configurations, and identity threat detection and response agents hunting for behavioral anomalies. And what's crazy is the efficiency here. These subagents pull telemetry from ultra-lightweight host agents running on the individual servers at less than 1% CPU load. They are grabbing logs and system calls without bogging down your actual infrastructure whatsoever.
Section 4. Dynamic Consensus Protocol. Now, you might be thinking, okay, but how do we stop this AI orchestrator from making a mistake and accidentally shutting down legitimate traffic, right? That's where the Dynamic Consensus Protocol comes in. Guardian Cloud ditches linear algorithms for specialized AI agents that actually debate and verify anomalies against each other. In Step 1, the ITDR agent flags anomalous file activity. In Step 2, the sysadmin agent cross-references that process with network traffic. Only in Step 3, when both domains unequivocally confirm the anomaly, does the master agent step in, synthesize the reports, and order a lockdown. It's peer review for AI, resulting in effectively zero false positives.
This multi-agent coordination delivers some absolutely staggering architectural benefits. First off, instant reaction. We're talking threat isolation in roughly 726 to 952 milliseconds, literally sub-second.
profoundly faster than any human could even click a mouse. Second, massive economic efficiency. It's a pay-as-you-go model that effectively replaces entire teams of manual monitoring. You also get total control with absolute transparency. No black box decision-making here. Plus, the code is self-healing. It actively detects bugs and live patches them without taking your business offline.
Moving on to Section 5, Human-in-the-Loop Governance. Look, handing over the keys to the kingdom to an AI is obviously going to make cloud architects sweat. Total autonomy requires an ironclad safety net. That's why Guardian Cloud operates strictly on a human-in-the-loop doctrine. The AI is fully autonomous when monitoring, analyzing, and even prepping solutions inside a secure sandbox. But, and this is absolutely crucial, deploying any critical change to the live environment requires explicit owner verification. The AI proposes, the human disposes, period.
And to make sure that human verification step can't just be bypassed by an attacker with a stolen password, AlphaCan mandates a rigorous 5-factor authorization matrix. We're talking a standard password, stacked with email verification, Telegram integration, a physical hardware TOTP token, and WebAuthn biometrics. By layering all 5 independent factors simultaneously, it becomes practically impossible for a threat actor to breach the management console and force a harmful change.
Finally, Section 6, AI Coding and Audit.
This sovereign AI ecosystem actually goes way beyond just reactive defense. It's built for proactive infrastructure engineering too. Using their specialized GLM 5.2 models, AlphaCan offers modules like G-Coder. This is wild. It's basically an interactive architecture meeting right inside your IDE. You give it a business objective, and the AI agents will literally debate the architecture in front of you, generating and refactoring microservices on the fly with full transparency. Meanwhile, the Total Audit feature runs deep structural analyses, OS configuration checks, and vulnerability scans. This closes 100% of attack vectors before a server ever even touches the live network. It is a completely clean start.
So, pulling this all together, we've seen how the asymmetry of speed has permanently altered the landscape of enterprise IT. Attackers are weaponizing automated, instantaneous tools to break perimeters. If your adversaries are running autonomous systems, trying to defend yourself at human speed just isn't a viable option anymore. Guardian Cloud's multi-agent AI architecture levels that playing field, combining sub-second reaction times with uncompromised human oversight. Which leaves us with one very real question for any organization managing sensitive data. As cyber threats scale autonomously, can your infrastructure defense afford not to?